the whole world at our feet, watching seasons change. Our roads were lined with adventure, mountains in the way couldn't keep us from the sea. Here we stand, open arms. This is home where we are, ever strong in the world that we made. I still hear you in the breeze, see your shadows in the trees, holding on, memories never change.
Hello and good evening everyone. Okay, let's see if it works, and if it does work then we can start to get going. Perfect, it does work. I can see myself, I can hear myself. Welcome back. And yes, it was a long time without streaming, I think like 4 weeks or something, so I'm actually really happy to be back, and I missed you folks. So yeah, what was I up to? Before I get to that, two things. First, Foxtrot Charlie is today's moderator, so if you have any questions at any time, just basically ping him. And do ping him, do use his nickname, so he can tell me on our private chat that there is a question. Now, the second thing is, today's topic is going to be basically the continuation of the stream we had 1 month ago, which is actually, well, finishing, I hope it's finishing actually, the CHIP-8 debugger, which I started to implement. I guess last time I did like the framework of the code, and now I'm going to continue on that and implement some more features. And I actually hope this is going to be the last episode on CHIP-8, and then we switch into VMs in reverse engineering, as in like probably next week. So next week is going to be either that, or it's going to be Google CTF tasks if I get my hands on them. Yes, and there is no mission today. I apologize, I actually didn't... I'm still catching up from my time when I was away, and I didn't really have time to finish that up today. I had like a whole day of meetings. There's already a question. Anyone aware of any solution for multiple? Yes, sorry, my English. Web services transactional execution. It's a question from Doug. I'm going to leave it there. I actually don't know. Cool. So let's maybe move it a little. Okay. So what was I up to when I was away? And I'm going to switch to my desktop because this is a story with pictures, actually. So yeah. Let's maybe click this. So first of all, there was, well, the Google Capture the Flag 2017 finals. I was actually co-organizing this event with, well, other Googlers. There's, you know, quite a lot of people behind creating a CTF, and this includes the Google CTF. Basically, during the weekend, we hosted 10 teams from which qualified from all around the world, and yeah, passed and won. So congratulations! And that's like this amount of money, $13,000. Then Spam and Hex was second, and LCBC was third. So congratulations, well done. Now it was like a full days of CTF, and well, there were, I don't remember how many tasks. I actually hope to go through some tasks at some point, but well, not today. So because basically I had to finish some testing, some tasks and so on, I had to cancel some streams 4 weeks ago, and yeah. After that, it got even more funny, and by even more funny, I mean I actually went knife forging. It's not something I would expect to be doing, but yeah. So knife forging. This is what a knife looks like before it looks like a knife, and it actually is like the intermediate process already. I sadly don't have a photo what happened with this before, like just a few minutes before, when I accidentally pressed the hydraulic press to match on it, and the blade, which was this, basically bent. And thankfully the blacksmith, which was giving the tutorial to us on knife forging, did know how to fix it. We also made the handles, and this is what like the knife looks like further in the process, and this is what it looks like at the end of the process. I would say like 50% of the work on this knife was mine, and 50% was the blacksmith, and all the know-how about how to make a knife and how to actually forge was obviously the blacksmith's. So that was pretty amazing. I had a lot of fun. And this is my tomato knife, by the way. And it's probably the sharpest knife I have in my house right now. Then I flew to Poland. This is a photo just before landing in Warsaw. I actually really enjoyed the clouds. Now, after I arrived in Warsaw, there was a flea market with retro computers. It's actually something I spotted while driving in a cab from the airport to my hotel, and like scrolling through RSS, and was like, oh, there's like a flea market for old stuff happening once a year, surprisingly close to my hotel tomorrow. So obviously I went there. I even bought some stuff. So I have 3 photos here. You could buy, you know, some old Amiga discs, and I have no idea what this is, but this looked pretty amazing. I seriously have no idea what this computer was before reading the piece of paper explaining it to me. Now, I bought myself a game for Atari. It's actually in Polish, so I'm not even going to bother inverting the camera. It says The Lords of Darkness. Władcy Ciemności. It's the classic edition, and it's on, yes, a tape. So I'm actually playing with the idea on like trying to decode the tape, like just with zero prior knowledge tomorrow on my Polish live stream. Let's see what happens. And I actually don't have a cassette recorder reader for my Atari, so I don't know where I lost it. So I need to figure out how to use this. Then I bought some these were actually like Amiga software which was attached to some old magazines, you know, with demos and stuff. They sometimes even included floppy disks, it seems. And there's like King's Quest here, well, a demo probably, there is Simon the Sorcerer. I enjoyed playing the second part, and Ishar 3, which is a pretty interesting RPG. Then while exiting the flea market, I actually found this. This is Canon fodder on, well, on CD. Oh, there's actually like another CD here, I didn't notice it. And it's for 3DO. I have absolutely no idea what 3DO is, I'm ashamed to admit. That being said, this is more the reason I wanted to buy it, because, well, if I don't know something, it means I need to learn about it, right? Then, moving to the next page, let me do this. There are actually HitCon qualifications next day, or the same day and the next day. HitCon is, I think, a Taiwanese CTF, and I think we qualified last year, or were barely able to qualify, or maybe not qualified, but we're close to it. So anyway, this year, basically Dragon Sector rented a house in Warsaw, since we were going to a conference anyway the next day, and played from there, and it proved really fruitful. The tasks were pretty amazing, and we actually, like, yeah, as you can see, we won the qualifications. So qualified from the first place, and a couple of folks from Dragon Sector are going to Taipei. Yeah, I had a lot of fun with a couple of tasks, and maybe I should talk about them more some other time. Okay, there seems to be a question. Now you need to buy a floppy disk reader for this, I guess. That's not actually true, because I do have, I think, 2 or 3 different drives for this, and I also have something called CryoFlux, and CryoFlux is actually a USB low-level controller for floppy disks. So even if this isn't for a PC, and it might be formatted in a way PC would not understand, using CryoFlux I can still dump the image of it, and I can, you know, dump the image on like raw magnetic data, basically. So that device is pretty amazing. Why not Google 3DO before buying? Console from early 90s that felt hard. I mean, just the fact that I didn't know about it was enough to spark my interest and buy it. So yeah, I mean, that was enough for me. Cool. So yeah, what happened? Then what happened was actually something called the Security Pwning Conference. It's a conference I co-organize in Poland. Co-organize, I actually like handle the speaker invitations and call for papers and some other stuff, and it was actually really awesome, and there were like quite amazing talks, especially if you follow Redford or SQB Kuczek from Dragon Sector on Twitter. Let's do this. DS Redford. They published the slides, and they had a really awesome talk on basically a Oh, this doesn't work. Maybe they banned him. Now it's here. All right, perfect. Yeah, they had basically a talk about I will call it support backdoor or something like that. Basically, it's a way to bypass the BIOS password on Toshiba business laptops, and the way they did it is, well, it's like this. If you lock yourself out of a laptop, then there's still a way to get into the laptop, but you do have to like phone Toshiba or actually be a support person for Toshiba, press some magical key combination, give them the PC serial, give them the challenge code, and they will give you a response code. When you type it, you can reset the password. Now, the process is somewhat complicated, and the guys wanted to unlock the laptop. So what they did is they basically did quite a lot of stuff which required an oscilloscope and FPGAs and other stuff, and desoldered some chips and controllers and other stuff from the motherboard of the laptop. and discovered that, well, the embedded controller actually is locked by a pin and they cannot read the firmware, but they did a timing attack that's actually like a screenshot of it, and they managed to brute force byte by byte the pin, and then they actually managed to dump it and find the key for the symmetric crypto used for this challenge response, and they could generate the response on their own without having to call Toshiba. And it turned out that actually Toshiba has the same keys for like 15 years, and the same key is used for firmware update signing for this embedded controller, which doesn't sound great, especially that the key is embedded on the laptop. But you know, you should use probably public / private key crypto here and not a symmetric crypto. So the research are pretty incredible, and Toshiba actually was really responsive, and they were like working on a patch and getting this fixed. So that's also pretty good. I guess I'm going to give you a link to Redford's Twitter and also to KrzaQ's Twitter. I mean, if you're into security, you basically should follow these two. They are absolutely amazing. So yeah, so that was that, and there were also old computers, and this is actually a PC, but there were also other on the conference, so you could, you know, be on the talks or actually go outside and play with PlayStation 1 or Amiga or C64 or some Ataris or old PC ones. This is, for example, I played quite a lot of 3 missions, I think, or 2.5 mission of Warcraft 1, which is the second major real-time strategy game I played. And then, and also this, which is, you might know it under the name Bomberman, or you might know it as Dynablaster or Dynablaster. This is my favorite party games, in all honesty, so I played a lot. So yeah, that was fun. And then I basically came here, and that was everything what I described, plus some other events lasted, I think, 4 weeks. On the conference, I actually met some awesome people. For example, Proton, he gave me this device. This device is actually, you plug it into your Atari, and like Atari, you know, the small Atari, 8-bit Atari, and you can plug an SD card here, and it emulates floppy drives, like 8 floppy drives. This is quite amazing. I'm totally need to see how this works. And he also gave me this. This also emulates a floppy drive by actually being a floppy drive. And this is a floppy drive for 3-inch. Don't confuse 3-inch with 3.5-inch. This is actually for 3-inch floppy drives. And this is for Timex, I believe. And yeah, it's quite amazing. Actually, was missing a floppy drive for 3-inch diskettes, so floppies. So I'm quite also interested in playing with it. From other stuff, I also bought this book, you might be interested in it, Breaking the Borders. I should probably flip the screen now, but whatever. Breaking the Borders is basically about Atari ST demo scene, and I found it on like some campaign on Kickstarter where this was finished, and the offer was trying to get money for the second volume, and they actually succeeded, but after moving to Indiegogo, I think, or something. Looks quite amazing. I didn't read it yet. So that was what was happening with me for the last month, and the reason why there were no streams. Now, from random news, only I guess a short one here. Yeah, I guess it's all over media. Intel Management Engine, which you might remember from Honorary Bot actually using on our streams to you know, control a machine he connected with WinDBG2. And yeah, so somebody figured out that how to basically using JTAG connect to it and get quite a lot of control, and then it was all over media that it's actually Minix of the operating system, the old school operating system there. So yeah, I'm actually really happy that Intel ME starts to be reviewed in a proper way. In all honesty, I understand why Intel says that, oh, it's fully trusted, it's okay, you can trust that, but trust us, but you know, trust but verify, right? I mean, that's the basics of security. So that's quite amazing. And apart from that, there are also another thing in Linux USB, the Linux implementation of USB. It seems to be somewhat, the drivers seems to be flaky at best, because somebody posted on, well, I know who actually, well, it's Sandler, $40 in USB drivers or something like that to the OSS security mailing list. So if you're actually into open source security, you probably should be subscribed to the OSS-security group. Just Google for it, you'll find it. So yeah, it's a scary time to connect USB devices. Now there are 3 questions. Who's gonna be at 0 nights from Dragon Sector? I actually don't know, honestly. Honorary Bot also asks, haven't I shown the USB JTAG on stream? I don't think you did. Introduce your teammates from Dragon Sector who are not shy about camera to talk about experience tips about CTFs. That's not a bad idea. I actually already talked with one. I need to talk. Oh, yeah, I need to make this happen. That's a good idea. And 8-inch floppy disks. Yeah, I have them. No, actually, no. Do I have them here? Yeah, I have them here, but the laptop is lying on them, so I don't want to break it. But yeah, 8-inch floppy disks were also a thing, but I personally never used them. I did use the 525 ones, but not these ones. Cool. So there are also like Nintendo weird format for Famicom floppy disks. I have no idea what the size, like 2.5 inch or something. It was pretty weird. Okay, so let's get back to CHIP-8. And how do we get back to CHIP-8? We start to find the code on, I guess, my drive. Okay, here we go. Oh, sorry, I have to load all the configs for streaming. I wasn't streaming so long, I forgot to do it. So first of all, so if my font is too small, I will probably be changing it during the stream. Now it's fine. And this is my code, I guess, for CHIP-8. It's also too small. Let's change it. Oh, right. This is a good editor. I can do just this. I don't have to look in the options. So what I implemented basically a debugger over there's a Pong here, which can I make it? Okay, it doesn't like me for some reason, but that's just a warning, so that's fine. Then if I run it with Pong I get a debugger, and the debugger is waiting for something, so I'm going to just go, and yeah, and it's working. So at least that's something. So what is the next step? Oh, sorry, there's another question. FireWire is not secure as well. Scary times to attach anything to the computer, including processor. So FireWire and Lightning actually have DMA access, and this is why they are not secure. I guess if you have the VTD and it's somewhat configured in a good manner, then FireWire shouldn't be a problem. Otherwise, yeah. Otherwise, you attach a FireWire device and you're basically owned. So if you have a laptop and you're not using FireWire, just disable it. Cool. So the state was that we had some... we had breakpoint implemented in a somewhat working fashion, I believe. Somewhere here, I do know I have to split this code, but again, I'm not going to do it. Oh, seriously, where's my breakpoint? Okay, hit. Yeah, here we go. We have basically a couple of debug commands already implemented. One is cmd breakpoint, which creates a breakpoint. One is quit to quit. One is run to run, which I just did and did use. And that's about it. I actually have some aliases for all of them. So if I type Q or quit or exit or buy, it will exit. If I type run, go, start or whatever, it will just go. Okay. So, oh, by the way, if you're not seeing yourself there and you did send me a donation, then apologies for that. I still don't have it automated, and I learned the hard way that basically if you send a super chat messages, I have logs for that only for like 4 weeks, and obviously since I had a 4-week break, I lost some logs and I'm trying to recover them, which isn't easy. That being said, it's mostly up to date. Thankfully there weren't that many donations. Okay, question. I'm not a security expert, but I think that dark web is just a normal network, but people make it like a very dangerous place. What is your opinion about it? Well, I actually somewhat agree, as in it's a network protocol, right? And it's called the dark for some reasons, but yeah, it's just another network protocol, more complicated, more about anonymity than others. I mean, like for example Tor, right? And yeah, I mean, I know that journalists and other people love the term dark web, but they think that describes some, I don't know, another different network than the internet, but obviously it's just like using the internet protocols, wrapping them around, and so like the onion protocol and so on. As for what is hosted on some servers, well, I don't have any hard evidence, right? But it seems, based on the articles, that there are some... Well, mainly what goes to mainstream media are articles about, like, just another drug-selling forum found on the dark web, or, like, another forum selling nasty stuff. So yeah, that's, I guess, adds to the image of dark web being a dangerous place. In the end, I'm pretty sure on the internet you can find similar websites, so... Yeah, it's an interesting thing, interesting field of research, but it's nothing magical. By the way, have you heard about P-code machine? P-code sounds like... what was the name? It sounds like Visual Basic Virtual Machine. That's what I'm looking for. Okay, let me open it and look for it. P-code, portable code machine, blah 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 blah. Or where is it used in Pascal? Okay, and I probably have been thinking about something else. What's the... Oh, Microsoft P-code. So I was thinking about Microsoft P-code. I didn't realize there is like a P-code apart from Microsoft's P-code. Sorry, I don't have an opinion on it, obviously, because I didn't hear about it previously. So I don't know. I just learned it exists. That's my opinion on it. Cool. Let's move on. What comments should I add to my debugger? Well, what I wanted to do is I wanted to create a disassembler today. I'm probably not going to add too many comments. I might add... Well, you can obviously, if you're having time, you can add quite a lot of stuff here. For example, the breakpoints which I have implemented are obviously breakpoints for instructions. So for instruction pointer. So if the instruction pointer reaches a certain address, then the debugger breaks the execution and goes into... Well, allows you to actually interact with the application. Now, there are obviously other types of breakpoints which do exist in normal debuggers as well, normal being for Windows, Linux, and so on, which are memory breakpoints, and here they are even having a virtual machine is even easier to implement. You basically check the address, the memory address, which is referenced by a given instruction, and well, check it against the list of memory breakpoints, and if the address is equal to or in the range of the memory breakpoint which was defined, and also, for example, the breakpoint was a read breakpoint or a write breakpoint, it matches that as well, then you break the execution. And that's really useful, especially if you know where something is in the memory, for example, a frame buffer, but you have no idea where the code is that touches that frame buffer. So you do a memory breakpoint on the range of the frame buffer, and then you see where the debugger basically breaks. It's super useful for that kind of stuff, where you, I don't know, also found a string in the memory and you want to know what creates the string or what touches the string, what reads it, so you can do the breakpoint on the range of that string. So the memory breakpoints are pretty useful. Apart from that, what else you could implement here? Well, I guess this already gives you quite a lot of basic tools. What some debuggers might give you is like run this code at this address with the following arguments. That might be useful as well. Obviously, changing the registry state and reading the registry state, this is something I don't have implemented, and I guess I'm going to start with it. That's also pretty useful. Does this machine even have registers? It does have a couple of registers, right? This is the moment where I'm actually going to run my, yes, the Wikipedia. So not run my, but run a Wikipedia for CHIP-8. Perfect. And there should be some, yeah, there are at least 2 registers like this. And there's the VX family of registers, and I think there's like 16 of them or something like that, or 8 of them. So this is what's going to be printed out. Then inspecting the memory is also another thing you want to have in a debugger. You want basically to be able to see what's on a given address and probably also change it, maybe interpret it as different things. For example, interpret it as bytes or words or dwords, or maybe as a string, or maybe as a pointer. So we might also implement that at some point. Sorry. Or perhaps you want to disassemble the code, and this is again something I wanted to do today. So let's start with the easiest, which is, well, print out the registers. So I'm just going to go here and add err as, well, maybe, yeah, err isn't bad, let's use err. It's going to be called debug cmd registers. And I am going to confuse it with run, because in GDB R is actually run, but in some other debuggers R is actually, well, give me the registers. And what do I want here for, like, reg registers as aliases? Yeah, as maybe regs as well, like, yeah, okay, cool. And now I need to actually create the function itself. So, yeah, registers, there's a question from Bartosz. There are dark services focused on hacking and darknet, like O-Day forums. Do you use any of them? Are they better? I don't use, I guess, darknet at all. It's like somewhere on my to-do list to actually do some research on how these protocols exactly work and if there can be anything funny done with them, but I've never got to it yet. You know, my to-do list is endless, basically, sadly. Or maybe not sadly, it's actually good to have a good list. That being said, well, I guess you can buy off 0 days in other areas as well of the internet. I mean, in some countries there are legitimate companies who sell you O days, right? So yeah. I'm not sure if there are like worse or better O days. I mean, it's up to the specific case, right? I don't think like where the O day is being sold actually affects too much the quality of it, and by quality I mean for what application is it and what does it give you. Cool. So CMD registers, then I do need to, okay, let me do this. Click and where is this? I'm missing. Why cannot? Oh, right, because I'm selected here. I was looking for why I cannot click this. Let me do this, and here I just want to see the structure, the general structure of my CHIP-8 machine. And okay, it's here. Cool. So now I can print and I can just print, I guess here, the state of the registers, where I'm going to start with, no, I'm going to end with actually the instruction pointer, so I, and, no, I isn't the instruction pointer, what is I? Oh, I know that what is I isn't really grammatical. It's a 16, no, it's a register for, okay, it's a 16-bit register, perfect. So, and I'm going to output it like in this format. I'm just going to printf it like this, not do anything fancy. VM, do I have to do? No, this is fine. I can just use it like this. I don't fully remember the code, so I might sometimes stop and think about what I'm doing. Then PC, and PC is also going to be, is it like, it's actually 12-bit, right? Well, this I should be probably 12-bit as well, due to the amount of memory CHIP-8 has, which is 4 kilobytes again. But I'm still going to output it with 4 digits, actually, 4 hexadecimal digits, for nibbles, if you will. And here, I guess I can output the other registers, so 4 and I. Yeah, no magic here. Now, I guess I'm going to do V, what's the naming again? It's V, right? VX, okay, so V I, and it's a 4-bit, so 4 bits means I have 16 registers, which means I'm going to go with a minus here and a 2 here. This actually means that align the field to the left, and the field should have two places, two placeholders for digits. So if there's only one digit, it will be, you know, a digit and then a space. And if it's 2 digits, then it's just 2 digits. And okay, then let's do this. This is an 8-bit register. And then I'm going to do 4 spaces. This sounds good. Now, I and VM V from I as index. Now, every sometime I want to actually print out a new line, because I didn't include a new line here, and I think maybe every 4 registers. Yeah, let's do it every 4 registers. So if I is actually divisible by, no, the rest of the I modulo of 4, basically is what I'm looking for, is equal to 3, then, well, put char, put car, whatever you want to call it. Okay, and this should work fine. Let's see. No, it will not work if I don't recompile it. That's how programming works. You need to recompile it, Coldwind. Perfect. I'm going to look into that in a second. Okay, now, yeah, just like give me registers, and here we have it. I don't like this. There are going to be 2 more spaces here. This is fine. Yeah, it's fine. It looks exactly like I wanted it to look, so yeah. Maybe I should move this actually 1 space here. Yeah, I'm going to do that. So this actually makes things really funny if I want to move V a little, because I have to change this to how to do it sanely. I don't have an idea how to do it sanely. I'm going to do it the normal way, which is reg name, I don't know, 8, and clear it, and then as printf. I know that the amount of text is going to be less than 8 bytes. That's why I'm using as printf. Otherwise, if I wouldn't know, I would use snprintf or a safe version of sprintf. So reg name, that's not it. And v, and now just this. Okay. And here, instead I'm going to use a string formatting, but I want it to be right aligned. I think it's right aligned by default, or I can make a plus here, it should be fine, but I think it's by default. And reg name here. Oh, come on. So that's fine, and I did say that I want to, yeah, it like this. Okay, quit, remake. Why does my prompt not include the space in this place? That's weird. Run it, see the register state. No, it should be one less actually. And yeah, I like the formatting better. So yeah, this is how you format stuff with printf. Cool. So register part is done. Now this warning 555. Here. Why this is not used? Okay, so if it's not used, I'm actually going to do this. Do you still issue a warning? No, you don't. That's perfect. Okay, there's a question from Dex. Gin, have you tried out Atom? I see you changed them to Sublime 3. I did try Atom I don't know, a year back, maybe 2 years back. I liked it. It was a little slower than I would like it to be actually, but I did like it. So there were reasons why I couldn't use it at that time and I never switched to it. And in the end, you know, as you can see, I'm actually using Sublime, which works great for me. I'm really happy with Sublime. I'm still learning how to do stuff in it with, well, the way I did it in Vim, but apart from that, yeah, I'm pretty happy with it. I'm still wondering if maybe I should like have only 2 rows here. No, never mind. Let's just leave it as is. So this is fine. And what next? I want to have the disassembler, as I said. So let's start with a prior step to it. A prior step to it would be actually just dumping the memory. So I'm going to have like, how do you dump memory? You dump it X in GDB, right? So I'm going to use the X as well. Debug cmd dump memory, read memory. I don't know, read memory. Maybe mem as well, and maybe memory as well. Cool. So now what I do, I obviously need to create this and copy paste this. How is it? It's 80 characters. Okay, that's fine. This is cool. Yeah, this is cool. Okay. There's a Vim plugin for Sublime. Yeah, I've heard about it, though in all honesty, I don't see a reason why I should use it yet. I mean, if I would like to use Vim, I would stay with Vim, right? That being said, yes, I know. So, yeah, maybe I'll look at it at some point. Cool. So in case of the read memory function, I do need actually an argument. And the argument is in a vector of strings. I guess I don't need this anymore, so let's do this. It's unused. I am actually going to use it. So if args.size, let's do a GDB-like format-ish. So it's going to be ish. Yeah, I'm not going to go for standard GDB format because that's quite a lot of parsing and I don't want to do parsing. What I am going to do then is I will settle for 3 arguments, I guess. The first argument is going to be what type of data, like bytes, words, or whatever. The second argument is going to be the address, and the third one is going to be length. Not the end address, but length. Length I always find it easier to use when it's like. So what about the set memory and set registers commands? I might get to them, I guess, after this, but yeah, let's start with dumping memory. That gives me what, 3 arguments, 4 arguments? 3 arguments I mentioned. So if it's not 3 arguments, then I'm going to actually output, well, sorry, but that doesn't work. Error. No, maybe usage. Okay, X, then type, then address, hex, and then obviously it's going to be hexadecimal. I mean, what kind of other address you would want it to give. And then count, as in how many items do you want to print out. And this is going to be actually, I don't know, hex or dec, like decimal. Apart from that, I'm going to also output, well, the possible types. So that's going to be B byte, and W for word. And I don't know if I care about anything else, like maybe S for C string. Would that work? S for C string? No, maybe C for character. And then, yeah, let's settle for this. Okay, and I need to return, obviously. Then there is the... Then we have... we need to parse them, actually, so... The address is going to... No, let's do it like this. If scanf with a string args of 2, 1, no, 1 is fine, dot cstr, because it's actually a C++ string, so I need to cast it to C string, or actually get my pointer, which is already in the structure. It's not really a cast. Neither is a conversion. And here I'm going to get X, because it's a hexadecimal address, and I want to put it in... So X already basically determines the type for me. X is, it's either going to be an integer or it's going to be probably an unsigned integer. So I do need to do that. Address, okay. I couldn't, if I would create a short here, for example, then that's actually a buffer overflow, as in I have 2 bytes, but scanf will write 4 bytes here, because if I would want it to write 2 bytes, then I would do this, like H, or 1 byte, HH, or 8 bytes, then L, or double L, or some weird stuff which Microsoft used to use back in the day. I think LL now works fine with Microsoft libraries. So this has to actually be int. Okay, and if this is not equal to 1, which means it didn't parse correctly, then yeah. Error, incorrect hex address. Incorrect address. Let's do it like this. Now, I am going to actually add one more thing here. If it's not 1 or the address is actually not in range. Sorry. So if address is greater than or equal to the amount of memory we have, which is 4096, do I have like any constant for it? I don't have a constant for it. I don't believe it. Oh, but it is a vector, so that's even better. So, oh, come on. So VM, mem, and size. If it's larger than size, then yeah, incorrect address. This is fine. Now, I also should double check if actually the first argument is, well, one of these 3 things, right? So if args 0 is equal to B, is not equal to B, because I'm actually doing the reverse, right? I'm testing if it's not it, then bail out, escape early. That way, if you approach it this way, you obviously don't have to create too many levels of your indentation. Okay, if it's not, I wonder if you can, oh, this is obviously a mistake on my side. If it's not any of these, then error, incorrect type, and return as well. And the last thing is actually the count. Now the count has to be an unsigned, which is pretty obvious. Though, due to reasons, I'm going to use int. And this should be count. Yeah. Basically the same thing. I'm just going to copy paste it, but change some things. Here we go. The last argument, then I actually, allows you to use either hexadecimal or decimal numbers. So I is fine, I is perfect, then count here. Or if, and this is where things get funny. Or if count is less than 0, because it could be less than 0. Or if address plus count, and this can actually be, no, because I'm checking if address is greater than 4096 here, I'm thinking if this variable can overflow, but I don't think it can, because it's just too small. It could overflow here, if this would be, yeah, it could overflow here. So, or count is greater than equal the memory size, then, yeah, then this is fine, and then it will not overflow. It can be equal to it though. Yeah, this is okay. We might want to print all the memory, so without the equal sign there. Incorrect count. Perfect. Now we have all the information we need. Hopefully it will not overflow, and we have to print it out in some way. Now, well, I guess there's like only 3 ways to do it, so let's start with bytes. And oh, you know what? I'm actually going to remove the characters, because I'm going to go for a nice hexadecimal code here, which displays the bytes on one side and the ASCII representation on the other side. Cool. So if args from 0 is actually equal to bytes, in that case, what I want you to do is I want to do for int I. Now this is going to have one funny bit, but I am not going to care about it, I guess. From int I equals to address, which this is going to be implicitly cast to int. There might be a warning about it actually, but I know the cast is safe, so yeah. Let it just be here, and why I is less than address plus count, then let's do it the other way around. I'm thinking if I want actually the value of the address there, or if I want the iterator there. I want the iterator there. Okay, so this now, so if you want a hexadecimal view, and the hexadecimal view looks like this, and by this I mean this, then, well, as you can see, it's actually interestingly formatted, right? You do have the address here, then you have 8 bytes, then you have like some breaker usually, and then you have 8 more bytes, and then you have like another breaking line or anything, and then you have the characters, only printable characters, obviously, because if somebody would include like you know, a new line here, then that wouldn't work at all. So yeah, formatting this is a little more funny, but let's try to do it. First of all, we do have to print. So it's like this. This is basically a state machine, and I guess I'm going to implement it like a state machine, because why not? So there are a couple of states here, and because it's a state machine, I want to implement it as a state machine. This is its own state. It's actually not this kind of a loop. It's a kind of a loop which does like while like forever, basically. Now, what could be, well, what are the possible states here? So let's just create an enum called states. I know it doesn't have to be a state machine. I just wanted to have it to be byte hex states. Yeah, enum class. Okay, enum class is actually normal enum is like it can be an integer. It's basically an integer, but enum class is its own thing. They work the same otherwise. Now there are a couple of states, so state number 1 is going to be start of line, which means print out the address. So print out the address. Then we have state. After address we have, well, we do have the bytes, right? So we have up to 16 bytes, actually up to 8 bytes. So bytes. Let's just do it like this. Up to 8 bytes. I'm actually going to call it bytes 1 because there are like 2 halves of it. Then there is the separator, so middle separator. And then we have more bytes, so that's bytes number 2, the second half of it. Up to 8 bytes. Up to 9 bytes, yeah, right. And in the end we have, well, the, the characters, the printable characters, so I'm just going to call it chars or cars, however you want to say it. Table characters. And in the end there's also like a new line. I might remove this one in the end. Now, there are a couple of things here. First of all, I want I is okay. This is used in state bytes. And so if you're wondering what's a state machine, then a state machine is actually, let me draw it. It's basically you have a couple of states. And for example, this is a state which is called the start of the line, so I'm just going to mark it as st. And then we have a state called bytes, so b1, and then you have like a middle separator, which is like sep. And then we have like b2. I'm not going to include all the states here, but just these 3. Now, you have arrows from a state to a state where the and you have like basically a pointer which tells that, oh, I'm at this state and I'm executing this state at this point. And usually the state machine gets some input. And, well, in our case, it's basically, well, the bytes or like a counter and so on. And well, if the input is, well, in this case, if the input is any input, because we just print out the beginning of a line, the address, and then we move to the state b1. Now b1 has the counter, the I counter, and if the I counter, which is its input, and also the vice or its input, is like below 8, so the I counter is below 8, then it will actually continue to in its own state and it will not go to a different state. But when as soon as I actually reaches 8, then it goes to the separator. The separator actually only so if I is equal 8, yeah, then the separator actually, well, always moves to the next state, and blah blah blah, then there is the new line, blah, and then we go back to the start state. And this is a state machine. There's also like usually a state which says, well, okay, we're done. There's nothing else for us to do, and probably like the new line state is going to be the state which decides on that. So yeah, this is a state machine, and the way you usually implement it. It's super easy, and it's a super powerful way of thinking about parsers, about parsing stuff, but also about formatting more complicated stuff. So, and doing other stuff. So yeah, finite states, automata, and other stuff like that, do learn it. It's a good thing to know. Whereas the ping. And for counting, I would recommend s size t. It can hold negative values. I was wondering if I should use s size t. By the way, s size t, I don't think it's a standard type. I think that's like a GCC extension or something. Normally you have only size t. Anyway, I was thinking about it, but for these kind of values, I don't see a reason. If it was like larger values, you'd be operating on gigabytes or megabytes. Totally use size t or s size t. But in this case, nah, not really. I mean, int is enough. But it's still a good comment anyway, so thank you for writing it. Now, oh, that was a funny artifact. Okay. So, then we have like I is going to be used by these two states. Then we have the address, and the address is actually here, right? But we have two addresses because as you can see right here, well, we are first outputting this, like these bytes, but then we are outputting them again just as printable characters. So we are going to use two different addresses. I'm going to use address like hex maybe, which is equal to address at the beginning, and address like chars, or however you want to say it, which is equal to the same thing. And this is going to be used in the same state. So I'm not saying that this is the perfect implementation of a state automata. It's just a implementation and a way you can do it if you're in a hurry. And this is going to be used in the state chars or cars. Whoa. So this is not equal. This should be is equal. Thank you, Eodin. Cool. Do I need any other stuff? No, I don't think I actually need. Cool. So first, it's usually used as switch case. You obviously need current state, like a variable which represents this, and we start with star of a line. We could obviously create a new state which is like initialize, and it's outside of a loop, and then it jumps to that whatever. We just do it here. Then we switch over state, and it's a really nice thing because the compiler will now detect that we are either handling all the states or not handling them. So in case we are in the state which is new line, what we do here is we, well, print the address, right? And the address is obviously like 12 bits. So I'm just going to use I know 12 bits is free, but I'm going to use 4 nibbles for it, 4 hexadecimal digits if you will, and that's it. And I'm going to go with address hex. It doesn't really matter which one I use here. And then I change the state to state bytes 1 and continue. And this, goes to the beginning of a loop, and then again the switch case and tries to select the proper state. Now, bytes 1 is going to be basically before I jump here, I need to reset I. I'm basically going to if, and this is only if, the address, what I need to also is the end address. This is going to be useful now. And the end address is actually address plus the count, probably cast it into unsigned integer. Okay, now if the address is less than the end address, then we print the byte and do a space. Do I really want to do a space here? No, I want to do a space here. Okay, and I'm going to remove the space here. This is better. Yeah, it's better. So let's do it like this. To X and, well, the byte. How do I get the byte? I do mem add. Add will, well, we chatted about add, right? The difference between add and the, just using square brackets for indexing, that will actually check, do boundary checking. This is incorrect, this should be address hex. Get the byte, and we're kinda done, but we do need to actually increase this. And now, or else, if well, if we are already out of bytes, we do need to make some spaces here, because we will still need to, if you go here to the end of a file, you can see that, well, we need to do these spaces, so otherwise the formatting will just collapse. So we don't want to do that, obviously. Oh, come on, Sublime. Just 3 spaces, that's it. And I don't have to increase the address hex. Now, I do have to increase I. And if I is at this point already equal to 8, then I need to change the state. And when I change the state, I guess I can reset I, because why not? And I switch the state to state... What's it called again? Middle sep. Well, actually, I'm going to like change I. And... Can you... their best supervisor asks, can you check if the byte is printable? Oh, I can check with... Sorry. Again, you can check if the byte is printable with isPrint. Okay. What is isPrint? I think it's in... It's called C-types. isPrint. Yeah, in C-type, not C-types. Here we go. Okay. Is it a standard... It is here, so at least Windows does understand it. Now, I wonder if they consider actually like a new line to be printable or not. I guess we can use our bot on IRC, so I'm going to move, I guess, the IRC for a second here. So our IRC, and we have a wonderful bot. So we can do like isPrint, and then I don't know, let's do the new line and see what happens. 0, which means it's not printable. If we do A, then it is printable. If we do C, then it is printable. And if we do a tab is not printable, and a space is printable. Perfect. So this actually works well. Ooh, yeah, I really like that bot. I'm using it a lot. So thank you, the supervisor, for suggesting. I'm going to use isPrint for it. If I forget, no, I shouldn't forget. Okay, now, in this case we switch otherwise, well, either way we continue at this point. Now, we do case state bytes 2. This is going to be funny. I'm going to do a funny thing here, but in a second. First, the middle separator. Now, the middle separator has to reset I, and basically change. Oh, right. I need to. Sorry about that. I need to put a character. Let's use this as a separator, or just like maybe an additional space. Yeah, an additional space is fine. I usually went with this. And I also need to move the state to the next one, which is state bytes 2. Now, I am a lazy person, I don't want to copy-paste stuff, so I'm going to do like this. State bytes 2. Though, here, if state is equal to state bytes 1, then this. Otherwise, we move to a different state, and the different state is actually, what is it? Cars, or like characters. That being said, I probably need a new state, just another state to handle this part. So I'm going to do like a, before this, it's going to be a state and separator. Okay, so we don't move to characters where we move to this, the AND separator. Did I change the keyboard? No, I'm still using G19, like the same keyboard I've been using for a few years now. Why are you asking? Okay, this is the middle separate. I am going to copy paste it. This is like the amount of indentation I basically stopped being comfortable with, and this is really crazy for me. I usually try to avoid that many, well, levels of indentation. So the end separator is actually going to be using printf, and I guess I will make a space, and I am going to use this character this time. Yeah, this is fine. And do I need to get I to 0? Yeah, I guess I need Ned. No, not Ned Stark. And yeah, and now I need to move to chars or cars, however you want to say it. And here basically I do this. If Pavel, thank you for the donation, 10 PLN, and as you can see I still don't have this hooked up. Maybe I can do it this weekend. Anyway, Pavel says IDDQD, which is the code for invulnerability in Doom and Doom 2. It's a perfect code to have. There's also like IDKFA. It was quite funny because I had a chat with my French friend about the IDDQD code for Doom, because he also was playing Doom when he was younger, and he didn't remember the code, because the code he remembered was actually IDDAD, because, well, the French keyboard layout has, you know, it's not QWERT, you know, it's not QWERT, it's starts with an A. So, well, in France, the invulnerability code for Doom was actually IDDAD, which is, it took me by surprise, by all honesty. I mean, I know about keyboard layouts, right, but still. Okay, give me a second. Okay, so this is funny. Olgierd says that the keyboard sounds more clicky than it used. That's bad. I am sad that you are saying it, because I did get a microphone stand just so the mic will not get the keyboard, and it seems it's if you say the keyboard is more clicky, then I failed basically, and that the stand I had before was basically better. Honorary Bot says something which also looks like I guess Doom code, but it's in Cyrillica, and I don't really read Cyrillica, so I don't know how to pronounce it. It's called Cyrillica in Polish. I'm not sure how it's called in English. Like the alphabet that's used in Russia and some other countries. Okay, and now, what was I typing? Oh, right, the debugger. And here, if is print, I need to include ctype.h. Do not confuse this with ctypes from Python. These are totally different things. Yeah. Here we get a character, so I guess we need to like this thing again. I wonder what does this actually return. Well, whatever. It's going to be cast into an integer either way. So if it's printable, then I can actually, like, you know, no, I already don't like it, because what I'm doing here is I'm calling this a couple of times, but maybe I should let the compiler this. No, I am going to create a block, and in that block I am going to create a variable, and the variable is going to be of type int. Won't it? TB for byte. Yeah. Now, because I don't want to fetch it too many times, and I'm not sure if the compiler would actually understand that there is nothing changing in between. Maybe the compiler would. Yeah, it's not. It's AZRT layout in France, not, as I say, AWRT. So no, AZRT. azr and so on. Here put char. I guess I have to cast it to an integer again. Yes, put char actually takes an integer, not a char. Otherwise, what I do is, well, I can do a dot, or I can do a space. I'm going to go for a dot, just because. Now, I've already printed it, and this is incorrect. This should be the other one, which is, yeah. I do need to increase it, and it's incorrect due to one more reason. If this is actually greater than or equal, no, this is going to happen only if end address is actually smaller. Yeah. Okay. Otherwise, I do need to, well, I'm going to put just a space, new line. It's quite a lot of code if you want to, like, properly print it out, as you can see. And it's not going to be fully properly printed out yet. And I'm not sure I'm going to actually implement fully properly. So fully properly would be with addresses aligned to, like, here would be zeros. And the way I'm implementing it is not going to be zeros, it's going to be the address you wanted, which isn't necessarily a bad thing. It might be beneficial. Cool. If I is equal to 16, because this time I'm going up to 16, then I'm actually going to reset I, and I'm going to change the state to new line, right? Yeah, new line. I guess I'm not going to reset I here, I'm going to reset I somewhere else. New line, and either way I'm going to continue. Okay, that's cool. Now this I'm using because I'm declaring a new variable here. Oh, but the variable is actually declared here, so I don't need this. I don't need to create a new block here. These brackets don't really belong to the case, it's just a new block declaration, by the way. So state, new line. I wonder how many typos did I already make. Okay, state new line. What I need to do here is I need to check if I'm done. Well, either way, but that doesn't matter. Either way, I need to put the new line I am promising. Now, if address hex is larger or equal to end address and address whatever the other thing is. It shouldn't matter. I don't think I have to check both, but I am going to check both just in case, but I don't think I have to check both. Then that's it. We're done. Break. But break in case doesn't work, so... While not done, and I'm going to add a... Yeah. Done equals false, like a standard way of doing it. Actually, one feature I'm kinda missing in C and C++ is that labeled breaks, basically. So you can say break out of 2 levels of indentation of break out to the loop, which is labeled like this. Some languages have it, and this way I could use break here to break out of the 4 I had here. And, well, C and C++ don't. I still wonder if there is anything magical in these bytes you see there, which are leaking my memory state. I have 2 states called new line. Do I really have? Yeah, because I have it here, which is bad because I actually... Oh, right, because... Sorry. It's a typo. This should be... Thank you for pointing it out, Arthur. It should be start of line there. Now, if this is the end, then we're done. We're totally done, and we're just breaking here, or like continuing, it doesn't matter. So break is actually... Break would be for the switch, but continue is for the loop, because, well, switch doesn't have a continue. As you can see, I'm not using any breaks here, which you normally should use case with break, but yeah, I don't need to because I'm using continue everywhere. Otherwise, I switch my state to state new line again and continue. So state state new line, thank you, and continue, and that's about it. Now, do I have everything closed? This is, yeah, it looks fine, and I'm going to test it. I'm not going to finish it yet. I'm going. That's quite a lot. I did expect quite. Okay, I know that there is a sign-on-sign comparison. I do not care about it too much, because I already know here that it's actually it has to be signed. But okay, if you need me to actually do a cast for, I will do the cast for you. I already know it's unsigned because of this check, obviously, like this one here. Now, state was not declared in the scope. That's because I probably need to prefix it with this. Let's see if I prefix it, if it actually 37, so it's already here. If this already works. Yep, that's it. That solves my problem. So I'm just going to prefix it everywhere. Probably should do it with some macro. I don't care though. It's like just 15. Okay, 15 places. Okay, let's compile it again. Then I have a syntax error. Sweet, where is it? No, seriously, where is it? 655. Here. Okay, and that's it. Let's see if it works. I kinda expect it to fall into an infinite loop due to me forgetting some incrementation somewhere. But maybe it will be okay. Enough. So m is not found mem. It's okay. X, then b. This is fine. Then the address 0 is a fine address, and then I want, I don't know, 50 bytes. Yeah, and this is an infinite loop because I forgot to change the state somewhere. It was expected. But I do change it. No. This is the same typo I'm making the second time in a row. This should be start of line. This is better. Okay, again. Oh, it's actually, it should work. This is quite interesting. An interesting feature of the con host, the Windows console manager, the console window, the console application, is that it actually looks at the name of the executable, and if you input something and type enter, then it actually stores that information in a buffer, and you can like use the arrow up key to recall that information. It's like similar to the readline interface, but it's much simpler, and it's actually given to you by the console itself. And if I would press actually, I think F6 or F7, then I get a full list of all the comments I've actually inputted here. So that's pretty helpful. And yeah, this looks like it's actually okay. So I think this is the address where the things are loaded. Yeah, this looks fine. So it actually worked the way I intended it to work. Now, what you can do is you can actually make the same code which I've written, and it took me like 100 lines of code, as you can see. You can write it much shorter. I have somewhere short code, but I don't know where did I put it. I think I put it on my blog, but let me double check that. So if I do publish it, it's going to be in my notes section. That's like, yeah, this thing. This looks for hex. Yeah. Oh, okay. I'm not actually outputting it like the printable characters here. So never mind. This is just this part, and this part is as well easy, as you can see. Okay. Is there something like that for Unix? I guess you're asking about the... Sorry, are you asking about this part? Like, if yes, then no, but on Unix the readline interface is much more popular. And readline is actually quite magical, so I have somewhere like some script started to do like an episode on it. Anyway, let me just launch the Linux console here and man read line. Yeah, this is the function, which is, and this is like a huge magical thing which is configurable. It can save history, it can do quite a lot of stuff, and it has like a gazillion of shortcuts, and basically it's used by bash, it's used by GDB and other stuff. So you learn the shortcuts for like GDB and you can use them in bash or like some other similar applications which are using this interface. So yeah, it's not really built in the console application like on Windows, but it's even more powerful when applications use it. And if I would be writing this only for Linux, I'd probably use it as well, because why not? Cool. Now, and here when it's done, this is the moment when I just return. I mean, I'm done with the bytes. Obviously, outputting words is way easier. One thing, this was a big endian machine, right? Yeah, it is big endian. So let me output this. I guess I can copy part of the code. No, I don't really need to. So for you know what? I'm going to actually copy my code that I just showed you. No, honorary bot, no, like I do see the artifacts as well when scrolling. I don't see them on the screen. Like for example, let's do this. Oh, here. You should see the artifact here. I can see it on the preview. I do not see it on the screen. I don't know what's that. Like, why is it behaving like this? That being said, there are also like some other, like sometimes lines are missing in Sublime. Did I update to the newest version? I don't know. I have this. Does that answer your question? Do you have exploits for this? Or are you asking for about Windows? If you're asking about Windows, then no. Not yet. I am at 1703. Okay, this is better. Now, the address for me is going to be 4. I want to make the format somewhat similar so it doesn't surprise the user with a different format. And yeah, okay, this is fine. Now, what I'm going to print here is actually in force. And I'm going to actually step by 2. So this should hold true still, though this is going to be address plus, and size in my case is actually going to be count and size. Now here, to print it out, I actually need to decode big endian, so let's just do it really quickly. So uint8t by 2. This is exactly what I'm doing, but I'm going to do it still like this. vmm at address plus I, and byte 2 is address plus I plus 1, and my 16-bit number is going to have, like, I don't know, W, is going to have first byte, like the 0 byte, as the, well, it's big endian, so as the most significant byte, and the other is going to be as the least significant byte. So this is what I want to actually print, and here I'm just going to use the W. Now here, if it's equal to size, not size count. So at the end, I'm actually not going to... no, here, wrong. This is wrong. This should be +1, because this is the count, the number of words I want to print. It's not the number of bytes, it's the number of words. So here I actually have to multiply it by 2. And it's the same here, and it's the same here. So here this is fine. And this is fine as well. Do I want 16? I want probably 8. I want only 8. There won't be enough room for 16, so it's going to be 8. And currently I'm preferring to adding the brackets here as well. Okay, let's see if it works, or if it compiles, because as you know, it's copy-paste, right? So it's not going to compile, because I forgot to change something. Comparison between signed and unsigned. I guess I can do it with int. I mean, I seriously don't care at this point. I already have checked, but I is actually never going to be negative or anything funny. Like, it won't overflow, so this is fine. Now, XW address is 250. Did it work? No. Why is this incorrect? Or is it? 1, 2, 3, 4, 5, 6, 7, 8. No, that's correct. That's actually fine. This is fine. Is it 50? So it's 8. This is 48, because it's 6 times 8, and this is 2. Yeah, that's fine. So, okay, we have printing memory, and it seems to be... I don't know if it's printing correctly, little or big endian, but it seems to be, so this is fine. Now, the last thing I wanted to show today is the disassembler. I'm going to probably skip the setting the registers, and I'm going to skip setting the memory as well. Which these are pretty useful stuff when debugging, but I am going to skip them. I am going, however, to write a disassembler, or at least begin, I guess, to write the disassembler. So this is a nice name, debug cmd disassemble, and some aliases, some other names, disasm, and disassemble. Yeah, should be fine. Okay. Okay. Cool. I guess I can copy paste the... By the way, please let me know if you're on chat right now. For the next week, would you prefer to do the anti-reverse engineering VMs, or would you prefer to do tasks from a CTF or some security stuff? Because it's fine either way with me, but I would like to do what you prefer. Cool. Now I do need to do some parsing here as well, so I'm going to copy paste this. Wait, an architecture not supported by Capstone? No, Capstone actually supports, I think, like 8 or 7 architectures. So we have ARM64, x86, ARM, Spark, PPC, MIPS, Xcore, whatever that is. I have no idea what Xcore is. And this, I have no idea what this is either. So yeah, we're like, it doesn't support as many architectures as, for example, the one from Benutils, which GDB is using. I think that supports way more architectures actually. Okay, so now, how many arguments do I need? Oh, I guess I'm going to copy that as well. So if I guess I'm going to settle for 1 or 2 arguments. I'm going to go for a default argument. So if the size is not equal to 2 and the size is not equal to 1, I guess 1 the address, and second optional is the amount of instructions, the number of instructions. So this as address hex, and then optional count. Okay. Writing new processor in IDA as a plugin would be good. I actually don't. I've written half of the time actually. Though if you could actually Foxtrot add it to our list of topics. It might be for, I guess, Binary Ninja, it might be for IDA, it might be for both. But it is something I should probably prepare beforehand. Or maybe, I mean, for CHIP-8, I could probably do it like that. I just need to have the environment set up. By just that, I mean with a lot of Googling. A lot of Googling. Okay, count, that's fine. Now, count is going to be equal to 10. I want to disassemble 10 instructions by default. But if args size is equal to 2, and I guess I'm going to use this and this stuff is equal to 1, count, which is, yeah, this is also like decimal or hexadecimal. In such cases, this should be 1, obviously. Well, no, this is it, actually, because, yeah, I actually need to separate it. If it's equal to 2, then. If it doesn't work, then error, otherwise you don't have to do anything, because it's already defaulted to here, so yeah, that's fine. If it's not 1, then I want to have the error. Okay, now I am not going to require, I probably shouldn't, yeah, this is a kind of a usability problem here when I am parsing count here, right? I'm checking if it doesn't exceed the memory, and if it exceeds the memory, then it actually says incorrect count. Now, more user-friendly would be actually to truncate it into the maximum allowed size. In that case, like, I could do like some address and then 100 and don't care if I actually reach the end of the memory, and this way I am actually caring about it. So that's kind of bad UX, but I am not going to fix it due to the, well, this being a temporary project, which I am probably not ever going to use again, almost. Cool, this is fine, I just need to return. Okay, so count is fine, and now I need to get the address. I'm going to copy paste the code for getting the address here. This should be 0, obviously. This is okay. This is fine. Now, for and I equals, how to do it? 0 I is less than count type plus. Now, in this architecture, I think every instruction is actually 2 bytes, right? Just let me find what happened to my browser. Oh, here it is. Yeah, it's always 2 bytes. So that makes things way easier. Because I know that the address will always, well, increase by 2, right? Equals, and no, this is fine. And address is actually less than what? Less than address plus 1 is actually less than VM mem size. Yeah, this is fine. Plus 1 because, you know, I need 2 bytes to actually get an instruction, right? Okay. Now, here I need to obviously disassemble the instruction. So first I need to get the instruction. And to get the instruction, I'm going to again copy paste some code. As you can see, I'm doing nasty things on this live stream. For example, copy pasting a lot of code. Okay, so I'm getting this. This is fine. I'm incrementing the address later, so I actually don't need this. And this is fine. Now I have the instruction here. Okay, now I need to disassemble it. And to disassemble it, I'm going to go to here. Hello. Because this actually has, well, this is my, you know, my opcode table. I am going to add another field to the opcode table because I'm going to reuse it. And the field is going to be string, std, string, mnemonic. I guess this is fine. Now, or it could be, it doesn't have to be mnemonic. It could be something like an address of a function which actually is responsible for printing out this stuff. But mnemonic is fine for now. I would also really use the argument format. There aren't that many argument formats here. So yeah, I am going to go for an argument format, which is so where's my definition again? Here. Okay. So how to do it with the argument format? You know what? I'm going to start with a string, and I'm going to maybe change it to something else later. Argument. Okay. And now for everything, I do need to actually fill it. So let's try to do it really fast. Okay. And my order here isn't exactly the same as the order in the other thing. Okay. So this is call type. So what's the name of? Is there a name for these instructions? Because I do see opcodes, I do not see instruction names. Maybe, just maybe, I should not actually disassemble it, but just output the... No, okay, here we have the names, perfect. E0 is CLS, and there are no arguments. This is going to be just a full stop. Then EE is actually return, and there are also no arguments. This is sys, and we have NNN. This is how I'm going to just mark it. Sorry, 1 is JP. So JP has also NNN. Then I have 2. 2 is call, and call is also NNN. Then we have, what is it? SE. What's SE? Well, whatever. And this is X and N. Then we have 4, which is SNE, X and N as well. There isn't that much of it, so I hope this is going to go somewhat fast. XY. 6 LD, XNN, 7 ADD, and XNN, 8 LD, and sorry, what is it, XY. Then we have 8-1, that's OR. I'm going to do it like this, OR, and I think there's only like a screen worth of instructions, which isn't terribly bad. Okay, and I'm just going to copy paste this stuff. So XOR or XOR, I'm actually going to XOR ADD, sub, shift right, I don't know, subtract probably. I'm going to remove the spaces later, by the way. This is fine. JP, CX, draw. SKP, what is it, like skip? Structure maybe. Then we have LD, this is fine. This is ADD, then AD, and there are like some super instructions, but we actually do not support them either way, so I'm not going to do anything with them. Okay. So these are the instructions. Now, XY, 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 these arguments are fine. Here we have an N, and I'm going to actually copy paste this here. Then I have X and N, X, Y, N. This is only X, right? Yeah, because the rest is part of it. X, 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 X. Okay, this is done. So now I have everything I need. I have the mnemonic on the left, and I do have arguments on the right, or the format itself. Thankfully, this architecture has a really simple format, so this makes stuff a lot easier. Now, I am going to copy paste a part of the main loop which actually decodes the instruction. Where is it? Oh, it's here. Yeah, I am going to copy paste this totally. And here. Now, sorry, in this loop, I'm going to actually call another function. And the function is going to be Debugger, Disassembler, and W. And I guess this is going to return me, I don't know, a string? What is it going to do? Or is it going to print it? It's going to print it. And yeah, it's going to print it, period, with the address, so I need to pass it the address. Void debugger disassembler, and it's going to take the unsigned and 16 address and unsigned and 16 the word, which is, you know, the opcode actually, if you will. Okay. Now, the opcode table is actually in VM, and I'm not passing VM here, and this is not good. I do need to pass VM here. I don't think I need this anymore, so I'm going to full screen. Sorry, this went to another monitor. Right. I'm going to paste it as paste it as the first thing. So yeah, now we have access to it. And if the opcode, it needs to be called opcode in that case, actually if it matches, then it executes the handler. Now I'm not going to execute the handler. What I'm going to do is I'm going to print f stuff. First I'm going to print f the address. Then I'm going to print f the mnemonic. And then I'm not going to do anything more for now, but well, maybe the format, and I will fix this, change it in a second. So opcode is called actually entry dot mnemonic.cstr, because it's actually, you know, a C++ string, and then what was it called? Arguments. I don't know what it's called. Arg. Yeah. I don't know, args. Okay. And also a C string of this. And let's see if this already starts to compile, if it compiles at all. Obviously it doesn't, because why would it? Because my opcode table is private. Now I do need the opcode table to be non-private. I need it to be, or I need to make this function a friend. So yeah, I'm going to settle for the last. I'm going to make this function a friend of the other function, of my CHIP-8 class. So somewhere here, I'm going to declare this as a friend. This is a friend, yeah. Okay. And I do need... If you're wondering why the ending of a span tag from HTML just popped up randomly, is because I have some of my macro keys for HTML. When it's useful when I'm writing on my blog. Now you know that I actually do HTML formatting on my blog. That's a nice disclosure called wind. Okay, and this should compile. Blah blah blah. It's private. Well, I know it's private, but this is my friend. How dare you not show this to my friend? What did I do wrong? Maybe, oh, I know, because this is not defined beforehand. Okay, this is fine. I just need to do class CHIP-8. Ah, this is better. Still private. Okay, I seriously don't know how to fix it. So I could find out, like Google the answer in a few seconds, but I'm just going to move this into the public zone, because why not? There's hardly a reason to keep that private. Okay. Now, this is incorrect because it should be the address here. Okay, it works. Now, blah blah blah. Let's see if the disassembler works. So this as, and 200. LDD something, LDD something, LDD something. Draw something, LDD call. Well, that's... I'm not sure if it works, but well, it did output something, which is good. Now the problem is that it doesn't output anything when it doesn't find this. So I'm going to return here, and I'm going to do something like this. Okay, and this is fine. Now I do need to parse the parameters, and if you remember correctly, I actually have the really helpful functions called arg stuff, right? These ones, right? And I am going to use them. Now, though to use them, I do need, I think, to actually move them as well to the public section. This is bad code design, what I'm doing right now. I'm kinda ashamed of it, I'm sorry. But, yeah, whatever. In this case, it's not super important to get it perfectly right. Yeah, Frida is not a debugger. Frida is a hooking engine in JavaScript and / Python-ish. Okay, this is fine. Here. Now, I found it. Now, the arguments. This is the interesting part. What I am going to do here is I am actually not going to... I guess I'm going to make a space, because you cannot see the space anyway. So, yeah. Now, what's the order of arguments? I don't think that matters too much. If is equal to is empty, actually. So empty. If it's empty, then we're done. I mean, there's nothing more to do. Return. Otherwise, if that entry args is equal to, and now we start to look at the Wikipedia again. Here, let's say NNN, then that's the others, but first I would actually like to go for... Well, okay, let's start with NNN. This, by the way, this shouldn't be a string. Normally it should be, well, probably some enum, I guess. Enum, I guess. Doesn't matter. I'm going to use the 3x, I guess, here. So OX with an OX prefix. This is cool. And now VM get arg. And I give it the opcode. Fine, and return. And now I need to do the same, exactly the same thing for all the other types. Okay, so starting with, I guess, this 2, 1. Oh, this was easy. Now I am going to do a slightly funny thing. I'm going to put this here. Okay, so I can actually see all the types. Then we, oh, maybe it's better if I just look here. This is fine. I don't have this one. Oh, I don't actually have these kinds anyway here. So yeah, they're always like compounds. X is always the register, right? So that's v something, and then this VM arg x opcode. Yeah, this is better. Then we have xy, where both are registers. So that would be v and v. Okay. And I get x and I get y. I'm not sure if the order of parameters is correct. Is it? This is fine. Here. Yeah, it's fine. The order of parameters is like Intel-like. I'm not sure this is the actually used in CHIP-8. This is the correct way to use it in CHIP-8. But we can, I guess, test it somewhere here. No, they also use it. Like X is always first and then is Y. So this is fine. Okay, now this is already implemented. This is implemented. NNN is implemented. This XYN is not implemented. This is implemented, so XYN. XYN is pretty interesting because I guess it's going to be this, and OX, 2x, 1x, actually it's 1x, just like, yeah, x. Okay, and now I get x, y, and n. This is fine. Now I have only the sole x here, so v and x, and is it all? Yeah, I think it's all. So that's it. Otherwise, I'm going to like print, but you know, like just mark for myself that this is actually unsupported. So this here, and then thank you. Who spotted it? Piotr Majek, I guess, or their best supervisor. Thank you. Cool. Is it done? See, okay. This has 20. This looks pretty sane. load some stuff to some registers, then what is this instruction? Load this to what? To I probably? What is this? I'm going to inspect the memory there because I can do it with my super debugger. And A to EA. What is A? Here. Okay. So this is actually N, and N is actually supposed to, depending on what is it. Okay. So I guess I have to add some special cases here. So how do I add a special case? Here. Do I get the opcode? Yeah, I get the opcode. So if opcode and this is nice, not nice what I'm doing here, but okay. Then printf I. Okay. Else if the same, but I get actually a B, then I know that this is PC. Okay, it's not nice. It should work. Okay, need to exit. Did I save it? Oh, they want a parenthesis, right? Because in C++ the parenthesis would actually go this way, which is counterintuitive. In Python they got it right. I have no idea why C actually went this way. Okay. Let's try to disassemble it again. Disas and now I want 20. This works. Okay, this looks fine. Probably fine. Looks fine. This looks weird. So it's again then 2 FO. So this is FO and then 15. This is the timer. No, so this is, I guess, fine. It just for some reason I have LDs there. Where is it here? So sorry, 15 is load, I don't know. Timer maybe. This is going to be funny, but okay, sound. It's probably not the proper way to do it. Probably I should like do also the special argument type, but whatever. Okay, make run this as 220. Blah blah blah. Jump load to timer v0. Okay. Seems to work. So this is actually what I wanted to, I guess, achieve today, to finish the debugger in a way where you can actually disassemble code, and it maybe works. I'm not fully guaranteeing that it works. You can inspect the registers, you can inspect memory as I've shown, and yeah, this looks actually, yeah, looks fine. So I guess that's it. Now, I'm going to upload this code to GitHub, obviously. And next week, I'm going to, I don't know yet, what. So will this as OX, with OX work? That's a good question, let's see. This as 0 will obviously work, but OX 0 will also work. Does it work with OX 200? It also works correctly, so it seems scanf actually, at least the Microsoft C runtime library implementation of scanf does handle the OX prefix correctly. Sorry, yeah, here. Yeah, this works. That's fine. So you can see. Cool. So yeah, I don't know what I'm going to do next week. I hope to be able to do some CTF tasks. Otherwise, I will go to and do the VMs and anti-reverse engineering or something else. Just let me know if you have an idea in the comments. I will let you know before next week, or well, you'll see it, I guess, on on the Livestream splash screen, which is always created by Foxtrot Charlie, who was my moderator today. So thank you, Foxtrot, for being here. Thank you to everyone who was here. And I guess Mormus CTF is going to start streaming right about now, so I'm finishing my stream. Thank you very much again for being here. It's great to be back streaming. And see you tomorrow if you speak Polish or want to, you know, just see what kind of an animal is the Polish language, or see you next week. So have a great one. Bye bye, and I'm leaving you with some music, but no mission today.